Welcome back, dear students. You attempted the Part A practice paper on properties of fluids. Now the moment of truth. Let's check every single answer and uncover the why behind each one. Keep your scorecard ready. Here we go. Question 1. A fluid is best defined as a substance that deforms continuously under any shear stress, however small. The answer is B. That word continuously is the whole definition. A solid takes a fixed, recoverable deformation and then stops. A fluid never stops. Question 2. Under a constant shear, a fluid continues to deform or flow for as long as the stress acts. The answer is C. It does not settle to a fixed strain. That would be a solid. Question 3. The branch that studies fluids in motion without pressure forces is fluid kinematics. The answer is B. Statics is at rest. Dynamics is motion with pressure forces. Question 4. The continuum assumption is valid when the body dimension is much larger than the molecular mean free path. The answer is B. Then we can define density, pressure, and velocity at a point. Question 5. The SI unit of mass density is kilogram per cubic meter. The answer is C. Newton per cubic meter is specific weight. Cubic meter per kilogram is specific volume. Question 6. The specific weight of water is ρg, that is 1000 times 9.81, which equals 9810 newtons per cubic meter. The answer is C. Question 7. Density of mercury equals specific gravity times the density of water. 13.6 times 1000, which is 13,600 kilograms per cubic meter. The answer is B. Log this value. Question 8. Newton's law of viscosity is tau equals mu times du by dy. The answer is B. Shear stress is proportional to the velocity gradient, which is du by dy, not dy by du. Question 9. The SI unit of dynamic viscosity is Newton second per square meter, also called Pascal second. The answer is B. Meters squared per second is kinematic viscosity. Question 10. 1 poise equals 0.1 Newton second per square meter. The answer is A. So 1 Newton second per square meter is 10 poise. Water is about 1 centipoise. Question 11. The SI unit of kinematic viscosity, nu equals mu over rho, is meter squared per second. The answer is B. In CGS, it is the Stoke. Question 12. As temperature rises, a liquid's viscosity falls, but a gas's viscosity rises. The answer is B. They move in opposite directions. This is the classic trap. Question 13. An ideal fluid is incompressible and has zero viscosity. The answer is A. It is imaginary, used to simplify theory. All real fluids have viscosity. Question 14. The excess pressure inside a soap bubble is 8 sigma by D. The answer is C. A bubble has two surfaces, so it is double a droplet's 4 sigma by D. A jet is 2 sigma by D. Question 15. Mercury in a glass tube shows capillary depression because cohesion exceeds adhesion with angle of contact about 130 degrees. The answer is B. Water is the opposite, it rises. Numerical 1. Find the shear stress between two plates 5 mm apart with oil of viscosity 0.8 Newton second per square meter and the upper plate moving at 2.5 meters per second. Use Newton's law tau equals mu times du by dy. The velocity gradient is 2.5 divided by 0.005, which is 500 per second. So tau equals 0.8 times 500, which is 400 newtons per square meter. The answer is 400 pascals. Numerical 2. Find the capillary rise of water in a 3 mm glass tube. Surface tension is 0.073 Newton per meter and the angle of contact is 0. Use H equals 4 sigma cos theta over rho GD. The numerator is 4 times 0.073, which is 0.292. The denominator is 1000 times 9.81 times 0.003, which is 29.43. So H equals 0.292 over 29.43, which is about 9.9 millimeters. The answer is roughly 10 millimeters. Now, tally up your score, 22 or more. Excellent, you're exam ready. 17 to 21, good work. Below 17, no worries. Just revisit the concept video, burn these numbers into memory: water density 1000, specific weight 9810, mercury specific gravity 13.6, 1 poise is 0.1 and a bubble is 8 sigma by d. Grab more MCQ practice papers on our Telegram, subscribe for Part B solutions and keep practicing, dear students. You've got this. See you in the next one.